well, we can kind of skip talk to neighbors, because this was like for teachers too. So you can see that there's many ways to visualize that. Some people might think of 3 groups of 3. Some people might see a 3 by 3 array. And some people might think about a plate of cookies. So, but there's lots of ways that people think about multiplication, and in our minds, we only have our own view of it. So we often don't get to like talk to other people, learn other people's views, as we were growing up, because we were always going through just the algorithm, which is the step-by-step, step 1, and then put that 0 down there that no one knows why you do it, and move on. So with our kids, we're trying to really build up their prior knowledge of using arrays and using area models to make sense of the world around them and to build things. So we start off giving our kids some prior knowledge of building arrays. And this is what's called an array. If you have equal rows and equal columns, we call that an array in mathematics. And so we do lots of arrays with our kids. So we'll say, like, show us a 3 by 4, show us a 2 by 2. And so in first grade, second grade, third grade, they're building lots of arrays to build all those visual connections in their brain that's needed to be a good mathematician. Then we might move on to, like, in third grade, fourth grade, using tiles, which is a type of your array to show multiples. Like you can see 3, 6, 9, 12, and they can understand how multiples work. And I'm going to skip through some of these because I don't have a lot of time. Okay, so then we get to like third grade where we have that 2-digit by 2-digit multiplication problem. And so we use what's called the area model. And that's one way we show them. We show them lots of ways, but this is the way that really makes sense to kids, especially if they're building things in engineering. So we might start off with, like, over here, you can see I have my 12, and it's outside. Whoops. I'm going to mess that up, Michelle.
Oh,
Maybe not use the laser.
maybe it's not working. I don't know how strong those batteries are.
Maybe it's, I think it's Google Drive.
Oh, that could be too. It was swinging out today.
Yeah, my drive wasn't working today at all. So frustrated.
Yeah.
Some people like to use a frame and some people don't. Some people are confused by the frame and some people are confused when they're not. This is amongst everybody I've taught. Administrators, teachers. So you kind of have to fill out what feels good for you. So we build a frame, and then within that frame we're going to build it down. So they can see that you have like 10, 11, 12, 13, and then 12 going across. And they fill in to make that the rectangle. And here's where our 4 boxes come from. This 10 by 10 is our first box. And then we have the 2 by 10 over here. 2 by 10 over there. And then the 3 by 10, and then the 2 by 3. And when we add that all up, we get 156, which is the answer to a 12 by 13 problem. We try to, when we're first teaching them, make the boxes about the size of area they should be. So they'll build this and then they draw. As we move into like 4th and 5th grade, we just put the 4 boxes down. Or if it's a 3 by 3, then we put down the 3 by 3 boxes. And they don't worry so much about that, like scaling that area.
So the red box, I'm sorry to interrupt you.
Yeah.
Not always
No, ask questions. That's good.
like the same number, like times itself. Would it be like 3 by 3?
Well, you could do a 3 by 3 box, or a 3-digit by 3-digit is what I was talking about.
I would not like number 3 times number 3, where you have like 10
Yes.
times
So then if I was doing a number 3 by 3, then I would just put 3 single ones, which we call these are units. And that's the smaller ones. These are called units. And you guys can get them out and play with them if you want to build too. And then we call these our rods. We call these our flats. Because as we are
rods,
making
and
numbers, we are in our base 10 whole numbers. This would be 1. This would be 10.
So here's a
And
1.
this would be
These are all
100,
the
and we have
ones.
these that are 1,000. I didn't bring those tonight.
These are the
But as we
tens.
move into digits,
And these are the hundreds.
decimals, as we move into decimals on the other side of place value, we start calling this one, this is tenths, and this is hundredths. So we change our units. That's why we don't really give them we don't give this a name like 100. We just call it a flat. So our unit, our unit is going to be hundredths. Yeah. So we switch the units with the kids because that's really a very big mathematical idea that it depends on what units you're using. So yeah, if I was gonna make a 3 by 3, I would take 3 ones, if I was teaching them ones, like if these were units of ones, and then I would fill that square in.
Okay,
Does that make sense?
totally, thank you.
Okay, and it kind of goes back to that picture we saw before the cookies, where it's a 3 by 3 box. Some people like the frame on the outside, some people don't, and I just kind of show it both ways and let the kids decide what works for them, and teachers too, when I train them. So we have some multi-digit problems today. So I thought maybe you could try to build one of these problems on here. And it is a little challenging, so don't feel like, oh my gosh. I have teachers that it's even challenging for. But you want to start, if you're going to do like the 14 by 12, that's probably the easiest to build. And if you do that, then you're going to go 14 rows down and 12 rows across and fill in that rectangle. Does that make sense? Like I'm going to go 14 rows down.
Can you do
and
14
12 across,
rows
and then
by
I'm gonna
12
fill
rows?
in with these. How many of these am I going to have?
Look, I made a cake.
That's
I'm going to
awesome.
have one for
Let's move these
14,
over.
right?
So let's
And
do
then
14
12,
by
and then I'm
12.
gonna have 10 sticks
So these are your
for those
10
other rows,
sticks,
right?
okay?
10 sticks.
So
So let's do
making
10
that.
one
Just so you
way
get the
and
experience that
10
the kids
another
get.
way. And then we have 10, but we need to add our
Okay, so you
ones.
can do it two
So
if
how
you
many
want.
would you
It's up
add
to
to
you.
that 10 to make it a 14?
4.
Right, so get 4 of your 1 units out. And get one side to be 14 and get one side to be 12. Here, I'll give you more space.
And then can you kind of see what would be in your 4 boxes?
Okay, so that's 14, and then this one needs to be 12.
Your rods and your units, right? Those would be your 4 boxes. Your rods, you're gonna have
If we have 10 and we're trying to be
are gonna
12,
2 boxes.
2 more.
good job.
Yeah, perfect, yeah.
Here's all your ones over there.
One box, right? This is 1 box, this is 1 box, and then your units. Very good. Okay, and see the frame? I think the frame really worked for you. Yeah, it did. Some people like put the frame out and they're like, I don't get the frame. I'm like, okay, you don't have to have it. Yeah. It's okay.
Okay, Mommy.
Okay, so we have 14 by 12, and then what we do is we fill in our space. We don't stack them because then that would be 15. I think we go like this, but let's,
And you might like a frame, like she
yeah,
used a frame.
just like that, and then we fill in our space. So what tools do you have over there that you could use to fill in your space? Could you use a big one, some other littler ones? What do you think you could use?
We don't count those because that's. And that's why we put
Okay.
it outside the box on the last picture. I don't know if you guys saw that. It goes outside.
We don't need to fill that space in. That's like a free space in bingo, I think.
Counted in our answer. Does that make sense?
Maybe some of your 10 logs?
So when I do this with my kids and we're building and we're building and building, pretty soon they can start to picture what that's going to look like. So if I say let's do a 25 or a 21 by 23, they can start going, oh, I'm going to have 200s, right? And then 200s down here. So my answer has to be 400 or more. And
You wanna
they
build-
give them a
I just
real
wanna
idea to be able to
Well, let's
estimate
do this
numbers.
one problem and then you can
So
build
if I
however
say
you want. So we're going to
do a 30
follow
3
the
by 3, You're gonna
line.
be like, oh, that's gonna
Okay,
be
go ahead.
9. My answer's gonna have to be more than
Build
900.
whatever I want.
So it's like this
Put the
whole
next
idea of
10
being
there.
reasonable with numbers too, because
And then
you're building
fill
visual
in with
proof
your
of
ones.
it.
Right there.
So
Uh-huh.
we often will get to like where I'm doing 20,
Greens?
25 by 25.
Yep, those are your
and I'll
ones.
see kids
I'm
like this
gonna
in their head. They don't even build
A
anymore.
green.
And they're like,
So you want it to
621.
match. Okay.
Picture 25 by 25 in your head right now. Can you see the 400 in one box? So if you can imagine, if they're building like this, building like this, building like this, they're building some real brain connections for all that visual that they need. So some people are like, well, why are we doing that instead of just doing the algorithm? And the reason that we're doing that instead of doing the algorithm is because here's our real world applications. You're going to look at arrays and you're going to look at doing multiplication in biomedical. You're going to look at it in ordering your carpet for your flooring. I know adults who like, I just count on the carpet salesman to tell me what it's going to be because I don't know how to use that. My kids in 5th grade could go to your house and tell you, they measure, and they would be able to tell you how much your carpet's going to cost per square foot. Farming, it's used in farming, it's used in architecture, it's used in solar energy, it's used in making wind farms. Because they have to measure all of that.
Mom.
So all of these things that they're going out to the world, that's very different from us, they need to be able to build. And by doing this, it really gives them all that information, all that visual in their brain, so that they're ready to go out and do that. So area models like really, really powerful. And I kind of went over with you how we call it the mat, the rod. Some people call it the mat, some people call it the flat. So either one of that is appropriate. The rod and the unit, because we change the value of that as we go into decimals. I could change it anything. I could call this one the mat one. And then that becomes a 10 in decimal. Oh, it is the laser.
Yeah. I
So
think
they
the batteries
yeah.
are wonky.
It's that just when I use the laser though. That's weird, huh?
Yeah.
So when it comes to multiplication, do you guys not teach the way we learned it all anymore?
We do go to the algorithm. That really doesn't occur until like 5th grade. So you're gonna, in 4th grade, if you have kids who understand it and they can explain it to me, I'll move them into the algorithm. Any grade. If they were in 2nd grade and they understood it and can explain it, I'm gonna move them. Any teacher's gonna move them. But it's not really expected for them to know the algorithm until 5th grade because we're doing so much of this building.
So when they have a test, let's say, and they're gonna be their multiplication test, do they have these things to
Some
figure
kids
out
do.
their stuff with?
Yes, and then that's a good question because some of my kids do have them and they'll choose to use them and some will draw pictures and some will use the 4 boxes and some are doing the algorithms. But see, all of that kind of lets me know where the kid is in their mathematical thinking. If they're still using this, they're at a concrete stage of understanding it. If they move to drawing, we call that like a semi-concrete because they're able to make a picture of it and transfer over that concrete knowledge. And that's a big step in their learning. Like you'll see that in 2nd grade. They're able to do that. And then when we go from the semi-concrete to, we don't really have to scale like the 4 boxes, then we know that they're starting to get ready for that algorithm. Because they're really understanding when I add up those 2 boxes this way, 2 boxes this way and 2 boxes this way, and I put that together, I see where my 0 comes from. And so they really get that understanding of the algorithm, and so then it's pretty easy to teach them the algorithm after that, because they understand what they're doing. So if they're fighting the algorithm a lot, then we're probably not going to, if I have a kid using blocks, I'm not going to talk to them about the algorithm. They don't have enough experience. It would be like asking them to go read a college research paper, and I just taught them phonics. They have to have those developmental stepstones for it. And then I was going to show you how we use it with decimals real quick, just in case we have some parents here who are, there we go. So that's how it would look in decimals. So we redefine the unit for them, and then there's an area model for decimals. And they understand that those rods, it takes 10 of those to make a whole, so those are tenths, because they're parts of a whole. My mat would be my 1. And then we have hundredths. So it transfers over into decimals really nicely for the kids too as they go into decimals, and it gives them a better understanding of decimals. Kids really struggle, and even teachers struggle, and even everybody in the world struggles with fractions and decimals. You start talking fractions and decimals and multiplying and dividing, I can use this to show them how to divide decimals. And they really understand what they're doing. How to multiply decimals. Why do we? What's that saying that, because I don't say that saying, that they have a saying about. If you know how you invert it, I don't know, there's a saying about that. Teachers used to say that, but nobody really understood what they were doing. So, that's another thing. But, so that is the area model, and so hopefully tonight you can see the importance of that, and that it's not just some crazy box thing that we're doing. And you might see like some kids are making an area model.
You used a lot of them.
Some are not, and that's okay, because it's just the stage of their development when they're using it. Do you guys have any questions? Or does that seem pretty easy? You guys did really well, actually.